And now we come to the scalar product. When you first see this, you kind of think, this looks really complicated. It is not. It is really, really easy. Okay, just 2 or 3 examples and you're there. It's like so simple. Okay, why is this useful? Okay, the scalar product enables us to work out the angle between 2 vectors given that they intersect. Okay, so I've drawn 2 vectors on the board here. Okay, and the last example looked on the point of intersection. Okay, so if there's a point of intersection, these 2 vectors are intersecting. Okay, they all intersect at an angle. Wouldn't it be useful to know what that angle is? Wouldn't it? Yeah. Okay, the scalar product allows us to do that. Okay, now the scalar product is sometimes called the dot product. Okay, so instead of the word scalar product, you could use the term dot product. Scalar is the mathematical term, dot is just short. Okay, why is it called the dot product? Okay, because we write the scalar product like this: A dot B. Now, that is not a multiplication dot. That is a scalar product dot. Okay, so that's what we mean by the scalar product. So if a question says find that, it means find the scalar product. Okay, now how do you do that? How do you do that? Okay, well, the scalar product is defined as this. Okay? It's defined as the modulus of A times the modulus of B cosine theta. Okay? That is the magnitude of A, the length of A, times the magnitude of B times by cosine theta. Okay. Now the scalar product on its own is not very useful. Okay. What we want to do from the scalar product is work out the actual angle. Okay. And so we need to have another definition of the scalar product, which is this. Okay. Now suppose I call vector A. Tell you what, I'm going to rub that off. Suppose I call vector A this. The points with position vector x1, y1, z1. Okay, and position vector B is x2, y2, z2. By the way, I'm doing all my examples, you know, it's in 3 dimensions because, you know, there's no point in 2 dimensions. You know, 3 dimensions, once you've got that, 2 dimensions is easy, but you can have 2 dimensions if you want. Okay. So suppose you know that vector A is that and vector B is that. Okay. Now the scalar product A dot B is also defined as, let's write down x1, y1, z1 dot x2, y2, z2. Okay, written like that. And I've done it like that for a reason. What you do is you can do that times that, that times that, that times that, and add them together. x1, x2 plus y1, y2 plus z1, z2. Now, so I said that very quickly. I do that in class as well, so people don't suddenly start asking questions, because I do not want people to ask questions at that point, because I've just kind of stated that without improving it. The proof takes a little while. Okay. I don't know whether I'm going to show you a proof or not. I haven't decided yet. Okay, but go with it for the moment. Okay. So I've got 2 definitions of the scalar product. Okay. Hang on to the thought that I told you earlier. When you first see this, this looks so complicated, and you're probably thinking, this is the last vectors video I'm going to watch, but no way. As soon as you see some examples, it's just so easy. Okay? It always looks hard when it's in general form. Okay, so the scalar product is defined as that. It's also defined as this as well. You can just do that times that, that times that, that times. Remember, these are just numbers there. Okay, so you're just doing that number times that number, that times that, that times that, and add them together. Okay, put them together. Okay, you've then got that is the same as that. Okay, so you can write down that x1, x2 plus y1, y2 plus z1, z2 is the same as the modulus of A. Now, how do you find that? Use Pythagoras' theorem, of course. x1 squared plus y1 squared plus z1 squared. I'm sure you don't have to remind yourself of that, but the magnitude of a vector in 3 dimensions is found by using Pythagoras' theorem. Okay, and then the magnitude of B is x2 squared plus y2 squared plus z2 squared cosine theta. The only unknown is theta. Okay, because you'll be given what these are, so you can work out that. That gives you a number. Okay, that gives you a scalar value, a number. Hence, scalar product. That's why it's called scalar product, because it gives you a scalar. On this side, it gives you a number. times another number times cos theta. Your job is then to rearrange that and work out what cos theta is as an expression. And obviously it's just going to be that divided by that. I'm not going to write that down. You can if you want, but I'm not going to. So you just have that divided by that. And then you've just got a number, use your calculator, work out what theta is. Incidentally, like with mechanics work, with vectors work, geometry work, we generally give our answers in degrees, not radians. There's no calculus involved, so we don't use radians. Okay, so use degrees when you give an answer. Okay. I've got an example coming right up. I'll do it on a separate video. Okay. Please watch the next video. Honestly, this is so much easier when you see examples. Please give it a go. Great.